Hey grade 8s, your second lesson is on prime factorization. And what this means is we actually break down composite numbers until there are only prime numbers left. So yesterday's lesson was on prime and composite numbers. Now it kind of takes that to another level. So I'll show you what I mean. So just say we have the number, 1050. And we want to find out what are the prime numbers that make up, when you break 1050 down, what are the prime numbers that you're left with? So what you would do is, again, you would find factors of 1050. So one factor, or one pair of factors, would be 105 and 10, which means that 105 times 10 is 1050, right? But here we look at 10 and we look at 105, and these are still composite numbers. So we have to break this down even more. So what are the factors of 10? What two numbers that multiply together give you 10? Well, of course, we can do 10 and 1, but we're going to be in the same boat as if we just left it as 10. So we're going to use other factors. So 5 times 2 equals 10. And if you look at 5 and you look at 2, those are prime numbers. And again, prime numbers are that the only factors that these numbers have are themselves and the number 1. So, for example, 5, the only two numbers that when you multiply them together give you 5 are 5 and the number 1. And same with 2. So 5 and 2 are prime numbers. We're going to leave those as is. And now we're going to break down 105. So one way to break it down is 5 times 21. Now we look. Again, 5 is a prime number, so we're good. We can leave that. Now we look at 21. Now 21 is a composite number because 7 and 3 can be multiplied together to give you 21. And now we look at 7 and we look at 3, and those are prime numbers. So the prime numbers that we're left with are, and I like to kind of cross them off as I go. So 5, 2, another 5 there, another 3, and 7. And so if you were to go back and go 5 times 2 times 5 times 3 times 7, if you have a calculator with you and you do that, it will give you 1050. So all these prime numbers, when you're left with only the prime numbers, when you multiply them all together, they should give you the big number that you started with. And I'm going to do another example. Let's do 1,470, okay? And we want to determine the prime factorization or create a factor tree for this number. So we're going to break it down. What two numbers that when you multiply them together give you 1,470? Well, 10 and 147, when you multiply those together, give you 1,470. Then you look at 10, you look at 147. We know 10 is a composite number, so we're going to break it down just like we did before. 5 times 2, right? So the two factors that when you multiply them together give you 10 are 5 and 2. And we know from the previous screen that 5 and 2 are prime numbers. So now we don't have to break these down anymore. And then we take 147. And we know that 3 and 49, when you multiply them together, give you 147. And again, I say we know that 3 times 49 equals 147. Even if you don't know that, you could, just as a sidebar, you could take 147 and on your calculator go divided by 2. Then you divide by 3. Then you divide 147 by 4. And you keep continuing until you're left with a whole number. So for example, on your calculator, if you were to do 147 divided by 2, you are going to get a decimal. And we're going to go over divisibility rules later, but on your calculator, if you do it, you're going to get a decimal, which means those can't be factors of 147 if you get a decimal. But on your calculator, if you went 147 divided by 3, you're going to get 49. And so you know that means that 3 and 49 are factors of 147. So back over here, if you look, 147, 3 times 49, 3 is a prime number because there isn't any other two factors besides 3 and 1 that when you multiply them together give you 3. And 49 is a composite number because 7 times 7 will give you 49. And then we look at 7 is a prime number, the other 7 is a prime number. So now 5 and 2 and 3 and 7 are all prime numbers, and they're all the prime factors of 1,470. So that means that if you were to multiply 5 times 2 times 3 times 7 times 7, it's going to give you 1,470. And that's how you do prime factorization. So what I'm going to suggest is I'm not going to do another example. If you need to watch this video another time or perhaps a third time, please do so you are familiar enough to be able to answer the assessment question that I'm going to attach on Google Classroom. All right, guys, have a good night. I'll see you later.